going. Okay. Next. Oh, I was gonna change the pod, right? Whatever. We'll do it another time. No, no, wrong thing. Good health here. Going in here. Yeah, interesting. Okay, looks like we maybe have one viewer. Start with. Maybe some more people will join, but that's okay. We don't need a lot of viewers. This is meant to be more of a record, so we don't need a lot of viewers. Okay, so thank you for joining me, whether you are here live or watching the recording on YouTube or Twitch. We have the Frontgrade GR740-MINI. We have the quad-core Leon 4 processors and a Lattice Certuspro FPGA. This board was designed for kind of a space development board. These are commercial versions of hardware processors and FPGAs that can be used for space applications. A previous live stream, we looked at some of the built-in examples that come with the GR740-MINI. Today, we are going to try to do purely custom logic for the Lattice Certuspro FPGA to deploy a RISC-V processor with a coremark benchmark output. We're going to be using the Lattice Radiant tools suite to get this done. This is my, I don't know, second time using Radiant. So I am not the best at the tools, simulator, and options, but hopefully my experience with Vivado and Libero help a little bit. We'll try to dig more down into that, but our goal is to use the Cronus open source RISC-V processor. It's one I like to play with, and then use kind of a pre-built binary that I've used for a while, which is some basic provides some basic coremark functionality with a basic UART output. And we're going to, the design isn't functional yet. We're going to do the functional design hopefully today and demonstrate confidence in its operation through simulation, but that doesn't really guarantee anything. I don't think we'll get to actually deploying it on hardware today, but we should get close. So the goal is we're going to create a testing design with the RISC-V processor. We're going to be able to do fault injection on it to determine its sensitivity, well, to demonstrate fault injection on the Lattice FPGA. Then we're going to apply TMR to it and get that running, and then we're going to push it all to GitHub and demonstrate RISC-V, TMR, and fault injection with a Lattice FPGA. That's kind of my goal of this. I also want to look at a Lattice Vex RISC-V design, and also try to implement a Leon or a Noel processor from the open library that Frontgrade supports, the Geister Frontgrade group has. But that's probably going to be maybe a month or two from now. We're going to do an open RISC-V design to start with, something more basic and not so demanding on libraries and third-party tools. Okay. Let's see, I think there's anything else. So it's basically this is a design that we kind of I did for SuperCon, and it's a Cronus processor, some VRAM, and a UART output. So we're going to go ahead and make a project and do our best to get as functional as soon as possible. Okay, and I want to do this from a blank project so everyone gets a little bit of experience with the Lattice tools. Why are they not responding? Oh, that doesn't look good for Radiant. Okay, we'll see if it works. This is funny. The tools just die as soon as I start to do this. Maybe we reopen it. Not doing anything. Yeah. Let's kill Google Chrome in the background. We're gonna let's kill this. Okay, sure, whatever. We're gonna try to reopen it. Hopefully it opens in a timely fashion, and we will try to create a new project. The DE10 Nano board. Okay, so the DE10 Nano. I assume that's the Mr. board, right? DE10 Nano, Mr. Right? Okay, I have a Deca 10, which is a Max 10 Intel FPGA. I also have the Analog Pocket, and the Analog Pocket is kind of related to the Mr. project, but still a slightly different FPGA. They have the non-SOC variant, while the Mr. FPGA you have the SOC variant. Does creating a project from this GUI not work? Really? Okay. We will maybe try from scratch again. Funny tools. Wow. Really? Okay. We're gonna try this one more time. What is this program happening here? Hopefully this isn't a video trying to get Radiant to work. So, Sabaloo Warrior. What do you want to know about the DE10 Nano board? Okay, we're gonna open up this one, and then I'm going to save as. Apparently, no, we're gonna do a save project as, and we're gonna do everything from scratch. I don't know why it's unhappy. Or okay. Believe I want to delete. Move. It looks like it rebuilds every time. Remove. Move. 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 Okay, we're starting from scratch. Keep these things. Let's remove these. Okay, let me pull up the files for this. File location, source. Just delete that. And this one, that one. Yes. I don't think we need that file either. Okay, cool. Yeah. Oh, we deleted those. Okay, well, we can refine them later. Move. Get them back later. Okay. So, let us first add the existing files. So we're gonna go to my previous project. That's over there. On FPGA Collab, we have Digital and Arty, we have a DUT, we have the Cronus. core, RTL, the core. Basically want all of these. Yep. And then we're going to add a existing file. We're going to we're going that one, and going to want, wish I could tell it what file to go to. Okay, here, that file. That should get us going. So what we're gonna do, I don't know why it has such trouble. Doesn't understand the black box that it has. So this is what we want as our top level. We're gonna do RISC-V. Okay. Yeah. I want to prove that the synthesized design works. That as well. Okay. Yeah. So Diablo Warrior. I do want to look at some Intel SoC stuff. Have you? I want to look at Agilex 5. So would you Cyclone 5 SoC versus Agilex 5 SoC? So that I prefer to look at the Agilex 5 SoC. It's going to be the newer generation of FPGAs, and their hardware is coming out in the next quarter, next few months. I'd rather look at that type of design than the Cyclone 5 SoC. It would be interesting to review the Mr. setup, but I'd much rather do the newer, the newer, look at the newer hardware instead. Okay. So how do I do it? Okay, I want to do a simulation of the, oh, okay. So we go here. We're going to do a post synthesis. I'm going to call it up. Fine. You're gonna want some. That's fine. We're gonna add the core for now. We're gonna add, let's add the Pico for Pico should be self-contained. Yeah, let's do this. We'll just do, that's weird, that's funny. Okay. We don't want to do that stuff yet. Okay, now we're going to open up the simulator. We're going to give it a clock and watch the system change a little bit. Okay. Why is model sin such a pain to get up and running, right? Like, I'm running this locally, I'm not running it remotely, and this is so painful. Why can't you be better? No. Okay, so we're gonna go ahead, file all, sure everything's happy, go library, and open up the Cronus V, and this is what we're gonna simulate. Oh, okay, so you got a GitHub repository from Sangman. Let's see what we got here. Absolute beginner's guide. Okay. But how expensive is the DE10 Nano? If we order now, it's $225. I guess. So, um, do you already have a DE10? Is that what you're trying to look for, or DE10 Nano? Do you already have one? Did you get one as part of a Mr. project and want to do custom hardware on it? Oh, why are you not happy? Why are the libraries? Why? I've been having issues just trying to get things to simulate properly here, and it's driving me insane. So these are a bunch of primitives in the design that you can't. Why did you give me the option to simulate it in the first place? This is so annoying. So annoying. Okay, let's go and try one more thing. Okay. Yes. Huh. Okay, so we want to add a memory module for our core module. Well, first let's bring in the memory file. We're going to add an existing file. We're just going to bump up, go to this one right here. Do we want not here? We get delete. Oh, I might weird. I have to go hunt it down here. Where'd he go? Okay, let me go find the file we need. Yeah, this file. Where's this file located? Oh, it's just, I just can't see it. Okay. Down here, we have to go to all files. And then we go here. And then we should see, why not hit all files? There we go. Add that. Okay. Great. IP catalog, we're going to do a dual port RAM. We're going to call it local mem. We're going to do 4096 32 4096 32. We're not going to do that. We're going to add byte enables. We're going to add a memory file. Cool. GUI could be better. Okay. So we have a source file right here for mem. It's a hex file. Okay, everything's happy. We're going to generate it. Finish. Okay, let's go back to simulation and add those two files. Let's see what happens. Okay. We killed the simulation. Let's try this again. Kill that. We're gonna add that one. Test bench. Next. Yeah. Yeah. Okay. This simulator is giving me pain lately. Okay. So, W Warrior, if you're still here. So do you have a DE10? Or are you considering it as a dev board? Okay. Let's see if this even simulates. Yeah, it didn't like simulating that. Kind of annoying. And if we try to simulate this, are you gonna have the same issues? We're missing a library. No one. Why? Why don't you add the library? I don't know how to add your library. Okay. Let's see if Google has any quick answers. Lattice instantiation of LUT4 failed. That helps me. Are you saying the license isn't load? Either. And then okay, I don't know what's wrong. And I can't simulate you by yourself either, right? I guess we could try to do it without simulating. I really wanted to prove it works. Yeah, why are libraries missing? I don't know where your libraries are. Okay, sorry. Not get angry at the tool, even though it should just work. Where are your libraries for your primitives? Really? Wow. Okay. I mean, they should be here, right? Is it because I mean, we're not ICE 40. Because we are FPGA. We have the Nexus. Do you not have the Nexus primitives in here? Yeah, I don't know why I can't simulate this. That is annoying. Well, I guess we'll try to get it all connected and figure out if it works. This is going to be a pain to debug if it doesn't work. I wanted to simulate it. Uh, hmm. Can we? You let me? You won't let me change tools. If we do this, can we change tools? Active HDL is maybe not installed. We could try just postgate routing, which would be really annoying. Um, yeah, we could try something. I don't want to do postgate routing simulation. It'd be a pain. Here's the IP catalog. Um, why? Hmm. Why? Why is the Radiant missing the appropriate library? Okay, let me demo that the memory is correct. So if we go properties real quick, switch this to the element, right? Oh, maybe I should try that. That would be funny. So we're going to synthesize the design. And this is going to look at the LMEM instead. Ugh. Hey, welcome to the show. I am struggling to use Radiant. It is making me angry. uh, okay. Um, so now we go back here. That's happy. We're gonna try this again. And drop that one. So this worked last time. So I'm curious to see if it worked now. Let's go back to the other one and we're gonna try using Simplify Pro. Curious if the license let me just use Simplify Pro. The only thing I can think is we have the ICE40 library, but do we have the Nexus library? I assume like Certuspro Nexus right there. I'm trying to open something while it's running. Okay. It loaded. Great. Now it's running simulation. Ooh. So why? So properly loaded the primitives. Why does it work now? Okay, see, it has a BB instance. It didn't have that before. Okay, let's go ahead, put the LMEM into the system, and it should have it. Just really confused where this came from. Okay, here's all the low level. Yeah, there's the BVE. Why was it? Okay. Yeah, look at this. Run dash 100 nanoseconds. Okay, cool. The memory works as expected, but it loaded the primitives appropriately this time, but not before. Yes, we're gonna quit. All I can think of is we look at the top level. Maybe it's bringing in the libraries, and we need to make a top level wrapper just to bring in the libraries. Maybe. Okay. I am confused, but I'm dot params. I don't see it bring any libraries, so it can't be that. Okay, let's go ahead and put the LMEM into here. Okay, so if we go back here into this lovely section, go back to the LMEM, they have these miscellaneous. We're gonna look at this guy right here, and we're gonna add the component to our component list. I did an entity instantiation. We're going to do a component instantiation. And we're going to get rid of the Xilinx reference. We don't need no Xilinx reference here. I'm probably going to have to bring those local, am I? Okay, so we're going to have to. Okay. Yeah, we're going to make all these signals local. Okay, I can do that. Maybe we'll just ignore those for now. Yeah, we should still be able to see them. We'll make them local too. We'll just have the clock, and yeah, we'll just do clock and the reset for now. Well, I guess we can leave these on the outside. Okay, back to here. We are going to do instantiation. Put it right here. Call it mem I port map. Bunch of really good signals. This is going to be the IMEM clock, the EMEM clock, and reset, EMEM reset, clock enable. Ooh, we do for that. Oh yeah, we have enables. IMEM enable, EMEM enable, IMEM write enable, and EMEM write enable. I wish these lined up better. How much does the GR740? I don't know. That's kind of like you call and you get a quote. If you go for the Certuspro FPGA by itself, right? Let me see. Lattice Certus. You can get, if you go for a Nexus eval, right? We do a Nexus eval card. They're like 100, I think. I think the Crosslink is the cheapest. Okay. So here you go. For cost. This one, which I have, is 130. That's for the Crosslink. This has 40K LUTs. For the Certus Pro, let's see. Good question. Okay, so this board, I think it's more expensive. Where do you buy it? Buy now. So this is probably the cheapest equivalent that is offered. $200. There you go. You can get something from 130 to 120. Okay. The out. Okay, and that's where it like splits this. those are the, okay. The right enables are a single port, not the, ooh. I guess you could just do the bottom byte. No, it could be any byte. Okay, we just slap dmem right enable. It's the byte. So you want enable there, but it's just 0. Okay. But we want this one here, that one there, read data. Kind of awkward how they did that. Weird. DN be DM there. Most important one, that's gonna be IMEM. IMEMDA. These zeros, but I guess we'll yeah. Then we need the address. The address here is 11. They did the full address here. Where local okay. Hopefully that works well. So the top 2 bits are 0. We're gonna do local memory access. Okay. We were just looking to do IMEM address DMEM address. Okay. And now what we need to do is make these local. Let's go put right here. Put that there. For those. This editor makes me cry. Okay. And let's try to synthesize the design. So we have now hopefully successfully loaded a program into our processor to try something. DMEM enable is not declared. Is that not DMEM right enable? Sorry. Okay, cool. Go ahead. Oh, okay. Cool. Finished. Oh, I don't do map at this. Stop that. Okay, now we're gonna try this again. Yeah. Sure. We are not going to run those. I want to see if system will be happy now. Okay. Okay, it's all compiled now. Oh, we have to change the top. My bad. FPGA tools are not the fastest. Okay. That's weird. Okay, let's try to get this going. Ugh, that's simulating before. Giving it simulating again. Why is this tool so slow? Not even using my, just a bad tool. That's annoying. Why can't you have, it's, you're not, it's annoying. Not even doing anything effective. Well, you didn't mean for you to go down there. Okay. Simulate. See if this simulates appropriately. Why? You worked fine. Why can you... You can simulate this, but you can't simulate... Why? Simulate just fine. Maybe I need to make a test bench that brings in the proper files. Yes, we could. Error loading the design. Oh, had another issue here. Maybe there's something in the script breaking. Okay, let's try doing this again. But we're gonna let the tool do the steps it wants to do. Okay. Yeah, 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 do all those things. Maybe that's how we bring in the library. Because you worked before. Will you work again? Ugh. Model sim models. Not even using my computer. I do not know why this is so slow. Is it a free tool? I guarantee that the paid version's any faster though. Okay. Okay, it pulled in the parts. Okay, now can I just switch what I'm looking at, or do I need to create a top level test bench for it? Simulate. Yes. Oh, okay. The tools, give the tools a minute. We'll see if they pop up. So it looks like it loads in libraries. Libraries. No, it still didn't load in low libraries. Okay. So let's try. That's annoying. Okay. Let's try making a test bench file. And we're going to copy that. So we're going to create a new file. We're going to call it a VHDL. We're going to say it's going to be Verilog, right? It's gonna be a Verilog file. Um, oh, sim. We're not adding it. Add it to the sim. You want me to make that folder? Folder. Uh, okay. No, not what I wanted. I want sim. Okay. Um. Okay. Um. So I don't think there's any libraries. We just gotta do like a very empty wrapper. Um. We we need these. Let's look at those real quick. So in test bench, we have these. I just want to make sure these, that's just the instance. That's just the parameters. Okay. We want those to defines. Yeah, we'll keep copy those defines, um, into our top level sim, I guess. Um, do if not defined top level test bench, timescale, module. We're gonna do top sim. And we'll need to instantiate it. Um, do that. And okay, let's get the dot. Um, so we go to here. That's our example. But we don't want to do an lmem. We want to do the cronus dot b. Okay. We'll need to make a bunch of signals. Okay. So that's bonus for v. Shouldn't care after synthesis. Then we just gotta grab these and make them signals. I think that's all. And put an end module at the end. Okay. think that's probably all we need. Okay. So need to make reg. You all will be reg. Reg. Oops. Okay, and spacing. Just basically gonna go 31. Bro. Do that. That one. That one. And that one's going to be a 2. Three. Three. And a 2. Okay. Then do like nice class rate. Okay. Hopefully that works. Let's see. Post synthesis. Going to remove this one. We're going to add this one. Okay, you didn't like. Okay, where is system Verilog auto ports? Okay, we want a dot star. See if that works. Okay. Oh. I think we need a it's this right here. If not defined, find that. If they have the ended effect. Not like the implicit. We go back here. Right. Okay. Do a dot end. Ugh. Beautiful. Okay. Oh, this is should work. I should find a better way to check the syntax than this method. Fine. Okay, so there's a HDL parser log. Um, does that parser log give us any more information? Parser log. All you do is say there's an error. 69. Guess we could try to run it regardless. Do not like error. I'm curious. Can you at least compile it? Unexpected, expecting. Oh, they're just not. Okay. There should be one there. Okay. Pops in. Yeah, yeah. Let's do it. Yes. Work. Ugh. I understand why people who use Lattice like to use the open source tools every once in a while. Come on. It only defines in there to be happy. I think you need to define the part so it pulls the right library in, which is annoying. Very annoying. Oh, it works. Does it work? Does it really work? Come on. I dare you. Oh, really? Okay, no, this is good. This is good. Yes, art out. Okay. Okay. This is good. This means that there Um, edit. GR. Okay. So here I want to find ESR out because it's line 3000 466. Okay. Expected 3, but found 2. So close. So close. And that was, go back here. ESR out. ESR inst. If not define, okay. Expected 3, found 2. Let us Google have anything? What would it? Okay, we're so close. Missing yes out. Um, what if we move that from the system? Retry the simulation. Curious that would change thing. Next. Otherwise, I guess we can go and change the child synthesis. Ah, had nothing to do with that. These are all warnings, though, not errors. Okay, here we go. The legal output. Okay, so this is the actual there. Okay. All loading. Okay, we just gotta fix these ports. What if we just don't instantiate them? Here's what it will say. You'll keep that. I didn't mind the system clock. Okay, whatever. Leave those floating, I guess. Oh, I am curious. Oh, do I don't want it so much. Terribly unique. Okay, we're working. Give me the dot. Bus may screw up, but we're going to do a restart. Okay. At this high, force a 1. Simulation clock. Okay. Run for 100 nanoseconds. Reset low. Zero. Are we getting anywhere? That's on the bus stuff. Where's the processor? Oh, did it not compile? What? To this guy? That's just Z. Just a clock. Okay, I'm so confused right now. The processor isn't here, but it's there. Oh, okay. Oh, so it's not compiling as we would hope. And that comes down to that little morning message we get. Why is it? Why is it? Guess we could do it in Verilog. I don't. Yeah, this is all a terrible issue stuff. We right here. Not compiled in library 4. Here's our core. Okay. It's the whole system Verilog thing. We're going to have to treat it as a module and then do an instantiation for it. Okay, sure, whatever. I can do that. Um, make a black box. Okay. Not declared. We declared. It should be happy. But we need to do a new component. And it's going to be the core. Sure, these basically forget the parameters. These are the ports. Ugh. Okay. Yay. Yay for doing things manually. Tools working different. Uh, out, in. Okay. Then out and in. Okay, we got that. Now data interface are these. So out, in, then probably do this in like VS Code or something. Out. Then we need those. Enable request data. Okay, and then we have these inputs. And software, timing. I think I just tie these to 0, don't I? I'll just tie to 0. And then we get rid of that. Now we have a component. Oh, is this where the core is taking 31? You want me to do 11 down to on those two? I don't know. No, this is X12. Okay, you're giving me error for that, so we'll fix that. So these ones you want me to pad. Okay, we can pad. Oh, no, we want to do it here. Okay. Can you not do system Verilog? Oh, this may have been a frustration not being able to do. Okay, we're gonna try one more time. Synthesize this design. Otherwise, we're gonna do Simplify Pro and see if that works. Oh, sorry, I got lost. Anyone talk to me because I'm just staring at this. What have I learned today is that this is a bad idea. Hmm. Okay. Synthesis reports, utilization. That's not enough. Okay. We apparently can't trust that. Does this work? Are you gonna say we have the appropriate? Yeah. You have an error at the tickle? What do you want me to do? I don't. Where's this tickle? I'm gonna have to pick a different processor. This is annoying. And okay. Fine, I don't care. Okay, go find log file or this tickle. Is it here? The simplified tickle, right? Simplified tickle. Okay, what we got? Line 72 failed. Why did that fail? Really? Really? It was line 71. Runs HDL file. Can I run this for both? SRF. Okay, we want the SRF file. Okay, nothing like debugging. Where's this SFR file? In log port. Oh. You have the SRF file. Or is it? You go back up one? I don't know necessarily where you ran. Could be here. I don't see it. Pipe. Sure. Try to open this one. Oh, yep, that's what you did. Fail to run. Log. There's something time-wise. I want to know why you failed. You. Okay, I think I found it. Entity. Oh. Okay, this is another Verilog VHDL thing. Ugh. Okay, this one might be easier. Okay, here's the error. Was a pain to find. But it looks like it doesn't like how we do that. Okay, I'm gonna try to fix that. It's gonna be the same issue. It is. I'm gonna hate this. Gonna hate this. How about we just rip it out? We're just ripping it out. We're not gonna worry about it. But we still need output. Okay, we'll just output those things. So, removing this for now. Here, we're going to rip it out, and we're just going to put those as outputs. Okay, we can do that. So, take that. Boom. Rid of that. We don't need that. Okay. We'll have to look at getting these done another time. Okay. I'll hunt that down and get it working. So far, okay, quick summary. So far, this tool has a pin, but for mixed Verilog, VHDL, and system Verilog generation. Vivado handles that much better. So, I probably need to stick to one and maybe do something more simple. So I will look at fixing this or doing a better a more compatible processor next time. Thank you for this journey and struggle in dealing with the Radiant tools.